Welcome students, this is Chandan Singh Negi. In previous lessons we have solved the problems of coordinate geometry chapters, and we have discussed the different type of problems. Today we are going to solve this is the ratio, this is called section rule in this coordinate geometry. And what is the section rules? This one, like if we have given a coordinates of a line segment and a point between these two given points, and then the ratio is given or the ratio is not given, so then we have to establish the relation between all these things which is given. Like this one, see, we call this a section rule, section formula or a rule. This is section rule or a section formula. Let we have this is Cartesian plane. This is x dash and y dash. This is Cartesian plane, and we have a line segment. This is line segment. This is the length of this one. This is A and this is B, line segment. And the coordinate of this AB is given. This is x1 and this is y1, and this is x2 and this is y2. And we understand this is what is x1. This like this one. This is x. Here this is x1, and this is x1, and this we know that this is x2. Here this is x2. X2 is from O. This is from here to this point. This is called x1, and this is called y1. This is called y1, and this one from O to this one, this is called x2, and that one is called y2. Right? So this vertical length is called y2. Now, and if there is a point between the AB, anywhere, this is AB, let's example this one. We have a chalk, and now I have break this chalk, this one, and from where this chalk has been break, and we know that if the length of this one part and this one part, we can get this point which from where the chalk has been break. So like this is a chalk, this one, and here there is a point. This is that P. This is the P, a position of the point, and the coordinate of this is that x comma y, right? And the AP length, that part of this chalk is AP length is this is M, and this is N. So that means the P is dividing this AB segment, line segment, in M ratio N. This is M ratio N. And now we have to establish the relation between this is Mn, Xy, X1, Y1, X2, Y2, right? So just check how to solve this one. First find out this one. This is a triangle we have. This is right angle triangle, and we have another triangle. This is again a right angle triangle. And just put the name. This is APB. Let this is C, and let this is D. This is C and D, and this one and this one both are the vertical length, and that means both of the lines are parallel. Here I am talking about this length, and this length is parallel. If this length is parallel, this one is also parallel, and this is 90 degree, 90 degree, and this is not a vertically opposite angles. It's don't write these are not two vertically opposite angles. Here, what we can say, do this one. This is parallel also. Here, this is parallel. So this angle is equal to this one angle, right? That is, this is corresponding angle on the same side of the transversals. Now, this one working as a transversals. Now, check this one. In a triangle, ACP and triangle ACP, this one, and triangle. Here this is angle A must be equal to this one angle P, but here this one angle is B. So now in triangle ACP and triangle PDB, ACP and PDB, this is we have x angle C is equal to angle B, which is 90 degree, and or any one of angles. This is CPA, that is CPA is equal to DBP, D angle DBP. This is corresponding angles, right? Angles on the same side. So that means if these two angles are the same, right, in these two triangles, that means these are similar. So these triangles are similar. This implies that the triangle ACP is similar to triangle PDB by AA criteria. Why we have done this one? Let's check this one. Because we know that if these two triangles are similar, that means the ratio of these sides must be equal, right? So this side, the ratio of the side must be equal. Just write this one. I'm just going to write this. AC upon PD is equal to CP upon DB, and is equal to AP upon PB, right? So that means this is the property of similar triangles. Now just check this, what is the AC, what is the PB, and just write down all these things. What is AC here? C. Here this is x1 and this one, write down, this is x, right? Here, from here to here, this is x and this is x1. So what is this one? That means this is x minus, if this eliminated from this line segment, so that we have, this is x minus, this is x minus x1. x1 is here, right? So this is x minus x1. And what is PB? PB. Where is the PB? This is PB, right? See this one. Let's check again this one. AC upon PD, not PB. I'm sorry, this is PD. PB is here. This is PD. I'm sorry, this is PD. So now what is PD? PD is, let's check this one. From here to here, this is x2, and here this is x1. If I eliminate this way, x from x2, so we will get this one. So this one is equal to PD, right? So PD is equal to, just writing this is x2 minus x, right, is equal to CP. CP is y minus y1. This is, I just writing, this is y minus y1. And BD is y2 minus y2 minus y, is equal to AP is, we have, this is M, and PB we have N. Now we have all these relations. This is x1, x2, y1, y2, m, and n. So that is called this is the section rule. And now just more we can sort out this one for the x and y, for x, y. So this one is equal to, for m and n, I just writing this is x minus x1 upon x2 minus x is equal to m upon n. And if we cross multiply this one, this we have, this is mx minus nx1 is equal to mx2 and minus mx. And if here, just check this one, this is nx, this is nx, right, this is nx. X is common, and there is no another things which is common in both sides. So let's convert this one which is common on the same side. So writing this is mx, this is plus nx, this is negative, left hand side, if you transform it, that will be positive, is equal to mx2 plus nx1. mx2 plus nx1. Now this is x is common, so here this is m plus n is equal to mx2 plus nx1, and now x is equal to mx2 plus nx1 divided by m plus n, right? So that is the rule for this is x, right? This is called x is equal to mx2 plus nx1 divided by m plus n, right? So we have established a relation between x, x1, x2, m, n. So that is called section rules. We can get that is we can get x2, or we have other things. We can find out x1, we can find out x, we can find out m and n also, right, from the given information. And same we can sort out for the y. Let's check. This is for y. Here this is y minus y1 upon y2 minus y is equal to m upon n, right? Again this is cross multiply. This is ny minus ny1 is equal to my2 minus my. Again same, that is which is common on the left hand side, and the rest of things on the right hand side. This is my plus ny. This is here transfer on the left hand side, then it will be positive, and this is my2 plus ny1. This is ny1. This is positive on the right hand side. Now check, this is common is m plus n is equal to my2 plus ny1, then y is equal to my2 plus ny1 divided by m plus n. So that is y, right? So this is the x and y we get from this relations. That is called sections rules, right? We can sort out the problems which is related, which if some of the points are given, and whether we have to find out mn or x1 y1 or xy, right? x2 y2. Okay, thank you students, thank you.